Hi, I'm Oseyeris, and today we're going to be talking about acceptable noise, heat, and vibration. Anything is noisy enough in here?
No, it's actually louder than a data center,
Oh,
but just by like 2 decibels. I mean, it's not that big a deal, right?
right. I'm sure people love that in the recordings and on the streams.
I don't know, man. Maybe. Do you guys like this? Do you like this really loud noise?
It's a nice ambiance. Makes you
Sure.
feel right at home in a data center.
Yeah, it does actually. It's really nice. It's like white noise all the time. And you guys were like, "What? What are you guys saying?" So my computer is really hot and it's really loud, and we got an air conditioner back here that's running for the purpose of keeping it colder in here, so we're not, sweating like we're in a sauna.
We won't
Just-
thermal throttle.
Yeah, that and it's not gonna thermal throttle my computer. Trying
Oh, yeah, that too.
really hard. Oh, you're gonna thermal throttle.
Yeah, I was going to thermal throttle.
That's pretty crazy. Anyway, so the purpose behind this video, is we're gonna show you how to take this kind of environment and give yourself a little more conducive environment like this. So we had a bit of a problem, right? Problem was that we have 3 computers running in this room. 2 of them were running at a lot lower efficiency than the third one. The problem we ran into is that these machines, mine specifically, I'll take the blame for that, was generating a lot of heat.
A
You know,
lot.
My machine by itself was pulling, with hard drives, CPU, and graphics cards, right around 800 watts of power just for my rig.
Just
And that's
for yours.
crazy.
That's not
I mean,
including
it's-
the monitors or anything. That's just his regular.
That's just my rig. So the capture rig was pulling right around 380 watts, and then your machine pulls right around 350.
Right.
Mine was generating a lot of heat. My system was running upwards of about 90 degrees Celsius when playing games. We basically figured that the problem was my graphics cards. Like, let's just call it what it is. The pair of 290Xs, we're pulling just those 2 cards alone while gaming was running right around 600 watts, give or take. But that's a lot.
So we have an auxiliary AC unit in order to compensate for all this additional heat in here. We have central air, but it could not keep up as we only have one air conditioner vent in this room. The issue we were leading into, our atmosphere was getting saturated with heat. Now we're thermal throttling. It's hot, and I don't like to work when it's hot. My brain don't work so well. We slowly realized that we're just attacking a symptom of a problem, not the problem itself.
So I know what you're all thinking. Is like, seriously, Kane, why do you need all that graphics processing power? And other than we need some graphics processing power here, in all reality, my situation had more to do with I needed specific outputs because I was running 2 4K monitors and a 1440p monitor. And in order to get all of those running at full resolution, I needed additional display ports, and these cards only have one display port, so I had to pair them up. And the worst part was that I couldn't even use them in Crossfire, because when you put them in Crossfire, you'll lose the ports on the secondary card. So it was just like...
The solution to the problem was get a different card, and possibly not 2 of them. The reality is, there's plenty of modern cards out there that are going to use significantly less wattage and have the amount of VRAM we're going to need to run all these displays. So, we went over to the store and we picked up one of these.
Now this one specifically is important because not only is it an RX 480, which is a 140 watt card versus the 280 watt card that the 290X is. It's also, it's 14 nanometer. It's a much smaller, much more power efficient card. It's got 2 display ports, 2 DisplayPort 1.4s, and it's got 2 HDMI 2.0s. It also has this massive shroud and massive cooling solution.
Right. And because the card is that big, fans don't even have to kick on unless you're gaming.
This card specifically it's an overclock, and it's got the 8 gigs of memory. So I wasn't sacrificing my video RAM and when it comes to rendering, and I'm not sacrificing noise for performance at this point.
After reconfiguring and changing all this stuff out, how did it turn out?
Surprisingly well. We dumped 2 280 watt cards and replaced it with a single 140 watt card, and then we took and dumped a 250 watt card or 240 watt card and replaced it with a 150 watt card.
Did we lose any performance and all that?
The only place we lost performance was on the capture rig, and that's because we're going from a 280X to a 7850, but we're not using it, so it's not that big of a deal. My machine, I've lost a little bit in maybe some render times. Maybe if I was running After Effects a lot, I'd be losing a little bit of time in rendering there. But for the most part, the RX 480 runs about 10% better than a single 290X.
Which is surprising. That just shows you the amount of technology improvement in the newer cards. So 14 nanometer is going to account for, why you got half the wattage draw on that, but the performance increase is going to just come from the fact that we have these new memory compression technologies for textures and everything else like that.
What's really going to blow your mind, and I'm still geeking out about this, the power consumption that we are currently pulling out of these two computers is less than the amount of power that we saved by swapping these devices out.
That's pretty impressive.
So to give you guys numbers, when you take the power supply inefficiencies into consideration, we saved 595 watts of power on these two computers combined. And we are now drawing, combined with the efficiencies taken into consideration, about 585.
So for the whole project, the total wattage consumption saved from the efficiency gains we've got might surprise you. It's actually right around 2,000 watts. I know you're thinking, whoa, those graphics cards were dealing with nearly that much. But actually what it comes down to is that auxiliary air conditioning unit was pulling some power, man. That thing was running about 120 volts, usually around, I want to say 10 amps at minimum. So sometimes on those compressor spikes, all the power in the room would dim.
Which is bad, because if you sneeze at the same time, you trip your breaker. I mean, that's really what it boils down to. I mean, that thing itself is pulling more power than all these computers combined.
Right.
And that saving is not so much in the saving in money, it's just saving in power, heat generation. The air conditioner unit generates a lot of heat.
Yeah, it generates.
It's got to go somewhere. We put it out the window, but there's a pipe.
Yeah,
that
you
leads
still have
to
to
the
have
window.
a pipe for that.
And it's so yeah, we saved a lot. And we were only drawing about 1,500 watts at the beginning with just the computers, not counting the monitors. And now we're pulling less than 1,000. We're pulling about 935, 940 watts just in the computers.
So instead of trying to come up with fancy liquid coolers, instead of trying to keep displacing all this heat, we went for efficiency, and we were able to reach that goal.
We ended up reducing the amount of heat being generated instead of trying to cool down the amount of heat that was being generated. So we ended up in a much better place to begin with. So this whole project was about solving a problem, not so much just treating a symptom, which is kind of what we're looking to move forward with. We want to find problems and find solutions that are actually going to mitigate the problem as opposed to just covering up and treating a symptom. So if you'd like to see more videos like this, you can always like, subscribe, comment, hang out, follow us on Twitter, follow us here, follow us there.
If you watch us on Twitch, you can come and criticize our microphones. But hey, you know what you won't hear? That auxiliary air conditioning unit or all of our PC fans anymore.
See you guys next time.